Hello, my name is Shruti Vinod, and this is Lab Report 1 for the fall semester of Physics 2211. So here, the goal of this experiment, or the purpose, is to observe the motion of an object that is moving at constant velocity over time, and it provides a comprehensive understanding of how net forces contribute to the velocity of an object using Newton's second law, which describes the total interaction between a system and surroundings and the effect on momentum in the system. I have listed important formulas I will be using to execute this experiment, but this will also be in later slides that I will explain more in detail. So the hypothesis is that unless there's an outside force, not net zero force, which is likely in a non-simulated experiment, the predicted position graph will line up with the actual position graph. So here, the system is a toy car on the ramp, and the surroundings are the gravitational pull and any resistance. So the initial conditions are initial displacement is 0 meters, initial time is 0 seconds, initial velocity is v. And as seen in this video, the toy car is moving down the ramp at a constant velocity. So here we see the formulas, very important formulas: momentum principle, position update formula. So here the momentum principle, net force is equal to the change in momentum over change in time, and momentum is equal to mass times velocity, and this is a vector. And the position update formula shows us that the vector velocity average is equal to the change in the vector momentum of the change in time. So vector, like the vector displacement, final displacement minus initial displacement over change in time. So here we see the experiment details where the setup is to find a smooth surface with as little friction as possible. This is what I did. And to give the toy car a steady push and allow the speed to stabilize and record a movement. Data collection was done by measuring and weighing the toy car, using these measurements to scale the distance traveled in the tracker program, setting up an axis to base the graph off of, and tracking the movement of the toy car in each frame. And analysis is editing the code accordingly, transferring predicted position and actual position and time data into a spreadsheet, and using data to create a scatter plot showing two position time graphs. So here are the data. So to find the average velocity of the object, the actual position data was collected using the tracker program, and the predicted position data was using the glow script code. So inputted starting position and average velocity, no net force, and gave time intervals. As you can see, here's the code. So, you change the mass, position, velocity, change in time, net force, which is 0, and final position. As we can see here, the code results show that it is a positive slope and a constant velocity. Now, talking about the results, there's a slight disparity between the actual position time graph and the predicted position time graph. The computation graph has a true constant velocity because the computer can eliminate any outside factors that would cause error, while the experimented graph actually shows an increase in velocity towards the end, likely due to a slight slant in the ramp, or anything on the floor or the table that the ramp was on, or another factor causing this ball to accelerate due to human error. And possible sources of error, as I said, was friction, or axes may have not been perfectly leveled or something like that. Finally, what if? How would the results change if the axes were flipped? The slope of the line of the graph would go from positive to negative, but the absolute value of the slope would still be the same. And what does it mean? How many forces are contributing to net force? Since this is not a simulated experiment, it is pretty difficult to accurately account for every force that would be present. But there are some common forces that we know that act on every moving object. So the gravitational pull of Earth is balanced by the normal force of the table that the ramp is on, and the small existing friction force also plays a role in the small difference between the actual and predicted position. Thank you so much.